Welcome to The Circuit, the new face of the Concentrics podcast and your compass in the dynamic world of concentrics. This season is called Tech Talk, where we will learn about computer vision, artificial and convoluted neural networks, and quantum computing. Join us as we journey along the tracks of technology and customer experience in the advent of new trends. This is Tech Talk, where innovation meets consumer satisfaction in the digital age. Welcome to the third Tech Talk Microlearning session. We hope that at the end of this microlearning session, you will have a better understanding of computer vision's core concepts and applications, as well as a basic comprehension of artificial neural networks and convoluted neural networks. Finally, learn about quantum computing. Let's get started. Everyone watching this video knows that this is a dog. Even a toddler might refer to it as a dog, but that's not a guarantee. Toddlers sometimes mix up cats and dogs. This is particularly true if they have not encountered a diverse range of dog breeds, colors, and sizes. However, once they've seen enough cats and dogs, they'll understand the difference. Human vision benefits from a lifetime of context, which helps it learn to distinguish between objects, determine their distance, determine whether they are moving, and identify any errors in a picture. Machines or computers use similar logic to comprehend the visual world. This technology teaches machines to accomplish these tasks, but it must do so in much shorter time, using cameras, data, and algorithms rather than retinas, optic nerves, and the visual brain. Computer vision is a multidisciplinary field. It can be considered as a subfield of artificial intelligence and machine learning. Computer vision enables computers to interpret and make decisions based on visual data. It is an area of computer science that allows machines to see, recognize, and process images just like humans. Let's see how computer vision works. In the first 3 years of our lives, we create 1 million neural networks per second. When we learn something new, our neurons in our brain lights up with an electrical impulse and sends the message about the new experience to other neurons, forming connections. Everything we know is shaped by these neural connections. Whenever we see a new type of dog, the same connection strengthens, making it easy for us to recognize an animal as a dog. With machines, we use similar neural networks, but those networks are artificial. Just a quick note, from this point, simplified explanations and formulas will be used to make the concepts understandable. Computer vision uses an artificial neural network similar to human neural networks. Artificial neural network is an advanced learning algorithm that can answer questions without any hints from humans. For example, when claiming an insurance reimbursement, the insurance company has to know how much it would cost to repair the house following an unfortunate event. There are applications that utilize AI to analyze images taken by insurance clients to determine how much should be compensated. The neural network examines the characteristics that must indicate damage and does so using mathematics. A neural network consists of several layers. An input layer gathers data, an output layer generates the final forecast, and hidden layers in between. Layers are composed of nodes or neurons that are all interconnected. Each neuron performs a calculation. Similarly, biological neurons get messages from the environment. Data are received via artificial neurons. The difference is that artificial neurons' data is expressed in a computer-readable format, like numbers for images. It refers to the color values of pixels in images. Neurons at the input level are not particularly significant since they merely receive and transmit info. So, let us focus on this node in one of the hidden levels. This node is connected to several nodes in different layers, and it accepts one number in each node, but it doesn't treat each connection equally. It evaluates each node based on its relevance or weight, which is represented by numbers. The higher the weight, the greater the node's effect over another. So, a node multiplies its input by the proper weights and adds them all together to get a single integer. These numbers will form the input for the nodes on the next layer. The weight essentially helps the application capture the data that is most important for the task, and layer after layer recognizes the information until the last node brings them all together and says, "Here are all the areas hit by the storm." An experienced evaluator can do the same job manually, but they must travel to the affected zone and inspect large areas, significantly increasing claims processing time. However, using computer vision's artificial neural networks, the affected areas can be analyzed without physical effort. Any visual data that can provide you full information can be processed by machines, saving time and money while providing a competitive advantage. This is the basic principle that all neural networks work by. They can be different too for any image task. For image recognition tasks, convoluted neural networks are used the most. Convoluted neural networks were specifically created to work with two-dimensional image data and are extremely good in locating features of objects. Here's how convoluted neural networks works. Computer sees images as grids of pixels. As you may know, each pixel is represented and encoded as a mix of red, green, and blue of varying intensities. Here's what the computer will see if you enter this image. To simplify, let's set it to grayscale and lower the resolution. Using this color intensity map, the computer must calculate the number of automobiles in the parking lot. This data can be used to enhance parking rates or direct traffic towards less crowded areas. Convoluted neural networks presents the same logic as the normal artificial neural network. However, instead of multiplying the value by weight, we multiply a patch of pixels by a set of weight called a filter or a kernel. This is done because in images, the differences between the neighboring pixel values is important. Pixels with low value are darker and high value lighter. If the contrasting pixels are close together, it is a good indicator that we are looking at the object's outline, so we multiply this patch of pixel by the filter and receive 1 pixel. The filter moves across the images patch by patch until it transforms the whole picture, so the convoluted neural network not only extracts the value from the images but also reduces its dimension, making it easier to process depending on what feature we want the machine to find. We apply a specific filter. They are like tablets helping find needed features. This kernel can pinpoint the outline. Other kernel can figure out vertical and horizontal lines. There are kernels refining faces and separate face features. At this point, we have learned about computer vision and the basic principle of neural networks. It's time for our final topic for this microlearning session. Let's explore quantum computing. Quantum computing is a technology that uses the laws of quantum mechanics to solve problems too large or complex for traditional computers. Quantum computers use subatomic particles, such as electrons or photons, to store and compute information. They can run revolutionary algorithms that take advantage of quantum phenomena, such as superposition and interference, to perform faster or better than classical computers. Here's an example. Let's say you decided to play toss coin with your current computer. You will most probably have a 50% chance of winning. This is because in essence, classical computers tag head as 1 and tail as 0. If the same game is played on a quantum computer, the chance that you will win is at 0 to 3%, with 3% being attributed to operational errors. This is because classical computers use bits. Bits that can either be 1 or 0, quantum computers use qubits, which can either be 1 or 0 or 1 and 0 at the same time. It's called superposition. Why does it matter? Qubits leads to exponential increase in computing power and efficiency. According to Michio Kaku, a world-renowned physicist and the author of Quantum Supremacy. With the evolution of quantum computers, it is possible that by just a simple blood test, a person can be informed if cancer is possible 10 years prior to the diagnosis. With quantum computer, a secure communication through quantum principles is possible. It will also revolutionize various fields like materials science and aerospace. Today, we learned about computer vision, explored artificial neural networks and convoluted neural networks, and the possibilities with quantum computing. Thank you for watching. That brings us to the end of the third microlearning session. We hope you find the information valuable.